Hello and welcome everyone to LFI Educates. Now let us see what is stopping distance for a vehicle or a car. Stopping distance for a car or a vehicle. Stopping distance is that distance how far it moves, the car moves or the vehicle moves after the brakes are being applied. After you apply the brake, the car or the vehicle will move for some certain distance before coming to rest. So that distance we call it as stopping distance. You can write like this: when brakes are applied, to a car, the distance it travels before coming to rest is called stopping distance. Now, if you use the third equation of motion, v square is equal to u square plus 2as, then final velocity will be 0. This is u square plus 2as. So from here, minus 2as is equal to u square, or s is equal to minus of u square, minus you can take this side, divided by as. This formula, 2a, this s 2a will come down. So this distance we call it as stopping distance. Now let us do one question. Let us solve this question and see related to stopping distance. A car moving at a speed of 50 km per hour, the initial velocity of the car is 50 km per hour, converted into meter per second. If you multiply by 5 by 18, it will become meter per second, because 1000 divided by 60 into 60, 2325, so it is 5 by 18. That's why I'm multiplying by 5 by 18. So it will become 225, you can cancel it, 2 9s are 18. So it will become 125 divided by 9 meter per second. Then it stopped, that means v is equal to 0, final velocity. After covering a distance of 6 meter, distance s is given as 6 meter. What will be the minimum stopping distance? Again, another statement starts. So let us take this as case 1. This is case 1. So from here, v, u, s, you know, you can find out the acceleration of the car. So let us use this third equation of motion. We know that v square is equal to u square plus 2as. If we use this relation, v is 0, u is 125 by 9 square, plus 2 into acceleration into displacement is 6 meter. So you can write this as, this one become negative, minus 125 divided by 9 into 125 divided by 9. 2 times square, so we will do 2 times, but plus will become minus. That will be equal to 6 2s are 12a. So minus will be 125 into 125 divided by 9 into 9 into 12. That is equal to a. Now if you multiply them and divide it, you will get the value of a as minus 16 meter per second square. After you find out the acceleration, then we'll go for the second statement. What will be the minimum stopping distance? I'm doing here case 2. They are asking you to find out the minimum stopping distance if the same car is moving at a speed of 100 kilometer per hour. This one also 100 into 5 by 18. If you do, it will become meter per second. This one will get it as 250 into 5 times 250 divided by 9 meter per second. Here also you are going to stop the car, v will be equal to 0, and the acceleration you will pick up from here, the one what you got it here, minus 16 meter per second square. Again we will use the same equation, that is your third equation of motion. We know that we can write from third equation of motion, v square equal to u square plus 2as. Put the values. V is 0, u it is 250 by 9 square plus 2 into acceleration is minus 16 into displacement. Now you bring the term towards your, it's your wish, this minus term, if you bring it towards your left, it will become plus. 16 2s are 32. S is equal to minus 250 into 250 divided by 9 into 9, because it is given in whole square form. So this is not minus, this is plus. Minus became plus, plus will remain plus only, it's on the same side. So the stopping distance S is equal to 250 into 250 divided by 9 into 9 into 32. So if you calculate it, then you write the result in meters. You can go on calculating 2 16s are 32, 2 1, 2 2s are 4, 2 5s are 10, 2 8s are 16, 125. Further you cannot divide, you cannot cancel it. So what we'll do is multiply, and then this two also multiply and then divide it. 125 into 125, 125 into 125, 5 5s are 25, then 12 into 13, 36, 12 ones are 12, 13, 15, 15625. This is 15625 divided by 9 9, 81 into 8, 81 into 8, 81 are 8, 8 64, 648. Then divide it, you get the final answer. Let us divide and see how much we will get. 15625, if you divide by 648, 3 terms we cannot divide, this is 1, this is 6, so 4 terms we have to take. 6 2s are 12, 2 8s are 16, 6 1 in hand, 8 plus 1 9, 6 2s are 12, 6 1 1 15 minus 9 is 6, 2, then this 5 you can bring down, 6 4s are 24, 6 5s are 30, 6 4 times let us see, 4 8s are 32, 3 in hand, 4 4 16 17 19 9 1 in hand, 4 6 are 24 25. This is 3, 16 minus 9 is 7, 0, then decimal will come here. Cannot divide, so 0, here also one more 0 will come. 6 8s are 48, 6 9s are 54. No, we can divide it. This term we can divide it, one time will come around 24.1 meters, or you can write approximately 24 meters. Let us learn one more term, that is your reaction time. Reaction time is the time taken by a person to observe, think, and after that to act. It is the time taken by a person to observe, first first he has to observe, then he has to think, and then he has to act. So how long it takes to observe, think and act? That time we call it as reaction time. Suppose it's like this. One of your friend is holding one scale and you are asked to catch the scale with the help of your right hand or left hand, let it be. These two hands are for two different persons, you can think. Your friend is going to release. You don't know when he is going to release. The moment he releases, then you have to think and then you have to act. When he releases, you have to think and act. During that time, the scale has moved some certain distance. It takes some fraction of a second for thinking, to observe, to think and to act. Reaction time depends upon two factors. The first factor is that the person's presence of mind. It depends upon the person's presence of mind. And the second factor on which it depends is the complexity of the situation, how complex the situation is. So it's not all the same. Suppose in this case it is very easy that you already know that your friend is going to release the scale, so you need to hold it, so you are already ready. You have already observed. The moment he is releasing, you can see, and then but you can act it. But if something, suppose a fly is coming near to your eye, unknowingly when you are roaming in the road, suppose, that time you are not ready. So it takes some certain time to react. After you see suddenly, then you move your head or you close your eyes, then you react it or you act it. So it will depend not only upon a person's presence of mind, it also depends upon the complexity of the situation. The complexity of the situation. In this case, just like the example that I have given, let us say that distance moved by the scale before the person reacts to hold it. Suppose let us just take an example. Let the distance traveled by the scale is 0.21 meters. Suppose this much distance it has moved by the time your friend catches the scale. Then let us find out the time. Initial velocity, you know, it will be 0 here, because starting velocity before you release it, it will be 0. It is at rest, then only it starts moving. So if you know these values, you can find out the reaction time using the relation S is equal to ut plus half of at squared. Displacement, suppose it is 0.2 meter, 0.21 meter. Then initial velocity is 0, so this will not exist, it will become 0. Half of the object is falling freely under the action of gravity, so plus g you take towards gravity, is falling 9.8 or say 10. You can take the value of a as g and then you will get here t square. So this value, if you multiply 0.42 with 2, if you multiply, divide by 9.8 equal to t square. So therefore t will be square root of 0.42 divided by 9.8. On calculation, you will find out this one as 0.2 seconds. This will give us the reaction time. So two things, if you know, this one you know the initial velocity. If it is falling towards the earth, then you don't require the value of acceleration at which it is falling. You know the acceleration due to gravity of the earth is 9.8. Initial velocity you must know, and the displacement. For acting it, how much the body will move before you act, after observing, before you act, how long it moves. This value if you know, then you can calculate the reaction time. This is your last topic that you are going to learn in this chapter. This is relative velocity. Relative velocity it is defined as the velocity of one object or body with respect to another body or other body. Suppose two friends are running, one is running at 80 km per hour speed and one is running at 60 km per hour. To an observer standing here on the ground, he observes like this 80 km per hour, the first person, and the second person is running at 60 km per hour. But to him it is like this. But if this first fellow, when he reaches here, turns back and look at this fellow, then he will not feel that he is running at 80 km per hour, because the other fellow is also coming at 60 km per hour towards him. So he will feel that he is running only at 20 km per hour. He will feel that he is faster than the second fellow by only 20 km per hour. This 20 km per hour, we call it as the relative velocity. And even if this second fellow also, if he looks at the first fellow, he will feel that he is running 20 km per hour slower than the first person. He will feel that he is running at 20 km per hour slower than the first person. This velocity we call it as relative velocity. Mathematically we write like this: relative velocity of body A with respect to body B. We write it as, velocity is a vector quantity. You can put arrowhead also on the top, but without putting arrowhead I am showing you. VAB you write. This is velocity of body A with respect to body B. You write it as VA minus VB. Or you can even write VAG with respect to the ground, and VBG also you can write. Or you can write it as simply VA minus VB. And if we say relative velocity of body B with respect to body A, then we will write VB minus VBA. If I write like this, relative velocity of body B with respect to body A, then we'll write VBA. It is VB minus VA, or VBG, AG you can use, or this can be written as VB minus VA. So this will have to know the order which side to take, because sometimes it can be, here you can see the first person is running faster, so it will be positive. Relative velocity will be positive. And this one, the second person is running 20 km per hour less, so it will be negative. The velocity will become negative. These are all vector quantities. If you want to write like this in book, you will find like this darkened, but you cannot keep on making dark like this. Vector quantities, you can put on arrowhead, then that will indicate vector quantities. In vector, if you write this way, putting one arrowhead. Related to relative velocity, a jet plane traveling at a velocity of 500 km per hour. Let me take the velocity of the jet plane as Vj is 500 km per hour. Ejects its products of combustion at a velocity of the smokes that are coming out from the jet plane is 1500 km per hour relative to the jet plane. So the velocity of products of combustion, let me write this C, relative to the jet plane, it will be in the opposite direction. We know opposite direction of the jet plane, we will write it as minus. This one will be positive direction of the jet plane, 1500 km per hour. What is the velocity of the latter with respect to the observer on the ground? Velocity of the latter means for the products of combustion they are asking you the velocity. So we know that relative velocity of Cj combustion with respect to jet plane will be Vc minus Vj. This Vcj, you know the value 1500, equal to Vc minus Vj, it is plus 500. So it will become minus 1500 plus 500 equal to Vc. Vc is equal to minus 1000 minus plus, so you will have to do subtraction, minus 1000 meter per, no, it is in kilometer per hour, so we write kilometer per hour. This way you can find out. This negative sign shows that the products of combustion that will come out from the jet plane will be in the opposite direction. The negative sign shows that the direction of the products of combustion is opposite to the jet plane. Like this you can solve the numericals if relative velocity equation comes. Thank you and have a nice day. With this we'll end this chapter. See you in the next coming video. Thank you.